So let's get this morning started on the right foot, shall we? So I want you to think of the biggest professional failure you ever encountered. Got something in mind? Now think bigger. What we see here, obviously, is SpaceX with their Starship, right? So a marvel of engineering, ton of very smart people worked on this, ton of money in there. It looks great, looks awesome, but keep watching because at some point it exploded, right? So this was the beginning of the year, and even though it looks spectacular, I would say, obviously this is a failure, right? This is a big failure, you would say, and a very, very visible one. Yet the industry actually has a bit of a different look on this. If you ask someone in the aerospace industry, did this rocket explode? They say no, it didn't explode. It experienced a rapid, unscheduled disassembly. Right. So like we knew this was going to happen. We just didn't know when or where or how, but we actually want to turn this into a learning experience. And it was, right? So they collected a ton of metrics and telemetry data, analyzed this to death, of course, and ultimately found out that a missing tile caused a fuel leak, which led to enormous harmonic stresses that weren't modeled anywhere before the launch, which ultimately led to this rapid unscheduled disassembly. So was it a failure? Yeah, of course it was. But was it useful? It also was. Does it pay off? Well, I guess so. I'm pretty sure that this will never happen again, this same mistake, the same problem. And of course, we know a couple of weeks ago they had another rapid unscheduled disassembly, still under investigation, but I'm actually pretty convinced that it's not the same root cause. They will not make this mistake again. And that actually leads to this kind of progression, right? So you see this development from going from very complex and error-prone to something more simple and streamlined. And this doesn't happen by accident. It happens through accidents, as we can see. So I think at this large scale, we can see that, right? And it's like, well, yeah, good for them. They can learn from this. But when we think about ourselves, you might say, I don't really like failure. At least I don't like failure. It can be painful, right? It can hurt your ego. It can sting. So we usually try to avoid failure. And today I want to explore that with you. And I want to maybe turn this a little bit around where you think differently about failure and maybe also embrace it like the way it could be embraced with SpaceX and their development and everything that they're doing at their scale. And when you think about it, actually as a developer, you're exposed to failure daily, right? So we encounter compiler errors, we have test failures, we have failing builds. So there's lots of failure already happening in our day-to-day. And we look at it, we fix it, we learn, we move on. We have a failing test, we fix it, it's red, it's green, and then we learn, we improve, you do refactor, right? So that is what we do. So in that sense, you could say, okay, we're probably already good, right? We are learning from failure, and we're not that bad at it, apparently. But that's only part of the picture. And in a sense, you're right. And I've never seen a developer being offended by a compiler error, unless you were maybe doing Scala. But I think in the small, so in our development cycle, we're already pretty used to doing to learning from failure. Who remembers, by the way, Subversion or CVS? I'm dating myself here, but apparently lots of you as well. Remember how painful it was to make a branch, to experiment, to do something. And again, there also Git really helped us to easily branch, try things out, roll back, revert. So that's a massive boost. So I would say in the small, we're already doing pretty well as developers in terms of learning from failure. However, if you zoom out, I think the picture is actually pretty different, right? Because do all of our projects succeed? No. We're also sometimes late with projects. And if you look at an even bigger scale, companies are falling, startups don't find product market fit. So things are definitely failing, even though maybe in the small we are learning from failure. And another area where we see this is, of course, with production incidents in our systems. I mean, things go wrong, right? And we want to learn from that. Now, luckily, most of our production incidents are not as spectacular as a rocket exploding in the air. And we can usually say, well, at least there was an error message. But when you think about it, I think production incidents are closest to what we saw in the beginning. Something very unexpected happens. You didn't plan for it, but now the question is, can you learn from it? Now, you've probably all thought about this and heard about, let's say, the more generic concepts about learning from incidents. So how you can have blameless postmortems, how you should have perfect observability, how you should have good feedback loops in there, and also psychological safety in your team to speak up, having actionable follow-ups, and then actually also doing them. But that also is very great in the abstract, of course. But what I want to do this morning is actually look at two very concrete um, failures from the picnic perspective. And yes, we do fail as well. I'm not afraid to admit. To put this into context and to see this in a more concrete scene. So, for the first example I want to show, I must give you a fair trigger warning because I know we're almost all Java developers here, and we think the whole world revolves around Java. Well, this example actually involves Node.js, so just be warned. Okay. Um, and the scene is as follows. So the web team at Picnic actually rolled out a completely new web stack based on Node.js and Next.js. And they were rolling out many of our websites, including our recruitment websites. And at some point, this was running very smoothly, very nicely. Everybody was happy. And then we had our own small, rapid, unscheduled disassembly. What was happening is that actually people started having issues with the sites. And of course, it wasn't completely down. So it's one of these issues where some people had problems, others didn't. And quickly this escalated into something that needed to be fixed. But the question is, what needed to be fixed, right? This was a production incident. We didn't really know what was going on. So luckily, we did have a bit of observability. And we could see that the containers that were running this web application were actually experiencing very high increases in memory. And at some point, it got too bad, and Kubernetes started killing the pods, and then it leads to failing requests, etc. So there was really a very hard situation to deal with because we really didn't know what caused these memory leaks, right? So maybe it's very tempting then to dive in to try to find what we did wrong, but of course, you should first think of mitigations. And one of the things that the team observed is that the amount of requests actually caused this memory leak. So how do you decrease the amount of requests? Well, you introduce caching. So as a first mitigation, we introduced CloudFront, and that, as you can see, really had an effect on the amount of requests. So of course, this wasn't the solution, but it bought us some time in between all of these peaks of memory leaks occurring. But then, of course, the real fun starts. You have this big failure, this production incident. How do you get to the bottom of it? Well, at first, of course, you try to reproduce. So the team used, for example, Locust and lots of performance tests to reproduce this in the development environment. And there they actually also saw the same behavior. But then the big question is, what caused this? So you look at all of the changes you made, right? It must be something you have done. And they looked and they looked. They tried to revert to older versions. They tried to find out, hey, should we maybe do some performance tuning on our Next.js and Node.js code. And there were a lot of improvements happening, but it didn't fix the issue. So yes, the code got better, but it was still crashing. So then the big question is, was maybe something that we overlooked? Maybe something in our dependency, right? So if you look at Next.js and you search for memory leaks, there's actually a ton of open issues. No judgment here, but it is what it is. And we use Renovate to very diligently upgrade our dependencies. So we tried also reverting some of the dependency upgrades, see if it was something in the library there, but also no dice. So at this point, it was pretty hard to figure out what was going on, and we still had the same issues, even though we bought ourselves a bit more time by the performance tuning and the mitigations that we put in place. So then the big question is, what do you do? Well, interestingly, one of the leads of this team was actually on the ride home on the train and tried to reproduce this on his laptop. Because, well, what else are you going to do on your train ride home? And interestingly, it worked. So there was no memory leak on his machine. And that's always the worst, right? It works on my machine, doesn't work in production. So it turned out that he, in this instance, was actually running the application outside of a container in his local environment against a very old version of Node.js. Oops. But not oops, because it actually pointed towards the solution of this whole problem. Because in production, we were running Node.js 20. And apparently, when we tried to reproduce this again with an older version of Node in our development environment, everything was okay again. But then still the question was, what happened? Because we did not change this Node version, right? It was still Node.js 20 a couple of months ago, and it was still Node.js 20 now. And if you were observant, you may have seen the problem here already. But what actually happened is that Node.js had a point release that introduced also a memory leak bug. So in 20.16.0, they introduced this bug. And the problem is, and you may have already spotted this, that in our Docker file, we are building this image from what is called node 20 slim. And it sounds very nice, but it's actually not nice because it's a tag that points to a moving target. For every point release, for every minor release, this points to a different release, which sounds very convenient, but in this case, really threw us off because we didn't know that every time we rebuilt a container, even though there were no code changes or there were no changes from our side, we actually got a different version of Node. So super convenient, but also super annoying if it introduces a bug. So of course, the whole problem here is that we didn't have this process to get a good reproducible build in this container. Now, of course, we fixed this, and you can go even further than this and pin it to hashes, etc., and then the renovate upgrades on that, all fixed now. But it goes to show that even a very simple incident can lead to a lot of learning. And that's actually what happened, right? So what the team also learned is that even though it's tempting to dive in and to find the issue yourself directly, you first need to think of mitigation. And in this case, introducing CloudFront helped, and it was actually such a good idea that it's now standard practice across all of the other web properties that we have as well. So again, yes, a failure, but it also led to learning and a structural improvement there. And it's also for the team itself a boost to actually look at such a thing, because they learned a ton about doing performance testing with Locust, about performance tuning Next.js code, about everything that is happening in sort of the dependency ecosystem. So even though it didn't fix the root cause, it was still very important for the team to go through this and to learn from this and to be actually diligently involved in this whole process of addressing the incident. So the other thing to take away here is it's not always the code that you write that can cause issues. And I love the way this is put. So debugging is actually the art of figuring out which assumptions are wrong. And in this case, our assumption was, well, we're still on Node.js 20, right? What could be the difference there? Well, actually, that was something that we overlooked and something that we missed and something that caused a failure, but one that we learned from, and we actually put into place a lot of structural improvements due to that. The last one that I want to give here is actually to write good incident reports because, well, it allows you to turn them into conference talks. So keep that in mind. And the final line in this incident report was actually, this one needs to be framed, right? Because it is a one-line fix, but it took a lot of time and a lot of learning to get there. And there's actually a really nice book that I highly recommend around learning from failure, and it's called The Right Kind of Wrong. And this book distinguishes between three types of failures. So there's basic failure, where you are in a known context and something goes wrong just because you were not paying attention or because there was something that you didn't know, or a simple basic cause is the root. Then there are complex failures, where you are still in a known environment, but there are many complex interacting factors leading to some kind of failure. Usually there's more learning to be had there if you dive into those. And then there's also the notion of intelligent failure, where you are in a completely new environment. You're trying something very new, so you don't know what can go wrong, right? So think of SpaceX with their Starship, the biggest man-made object to ever fly, never done before. So you're in a novel context, so you're in for a lot of intelligent failure. Now, you can tell this is not an IT book because it doesn't contain our nemesis, the failure that just randomly resolves itself. But let's not go there, right? So I think what we saw in the example with Node.js is really an example of a basic failure. There is a single root cause. We were not diligent enough in actually pinning the version of our container, of our Node.js version. Now that's fixed, will not happen again. Lesson learned. But what I think is really cool is how you, as a company, can do intelligent failure, because that's how you push the boundary. That's how you get out there, and that's how you adopt new things. And for that, I also want to share one example from the picnic context. And for that, I need to set the scene a little bit. So, as you know, we're an online groceries company. We have an app, and in this app, we have a lot of interesting UI logic, lots of navigation, layout, etc. Very cool app. And in the end, it needs all of its data to come from our backend, of course. There's lots of services, databases, and a gateway there. And the app, whenever it needs to render something, will do a REST request, get the data, and then render it in the app. Pretty standard, but also pretty hard to manage and scale, because any change in the app, in the way it looks, the way the data is rendered, etc., it requires you to push through the App Store, get reviews, takes a long time, people don't always update, So that's quite painful, and all of these changes then also require work in the back end. The services need to be adapted if you have more data, different ordering, etc. So it turned out this was really slowing us down by having so much development effort involved in evolving our app. So what if we could have an app that is more like a lightweight rendering engine with server-driven UI? And that's what we wanted to work towards, where we introduce a picnic page platform that could actually be configured by business users, where business users in this case are people who are a little bit tech savvy but are not developers. So they could define templates and UI, and this would then be turned into server-driven UI and rendered by app, so that any navigational and layout updates could be pushed immediately rather than waiting for app updates. But of course, templates and UI are only one part of the equation because you also need to show some data in there. So how do you allow these business users to define what data to show in the app at certain points? And I already mentioned these are some tech-savvy people. So we already figured out that using SQL for that in these templates would be a great way. But yeah, we still had the same backend, Java services, databases, you name it. So how do you actually get from the one to the other? What is the secret sauce here? And that's when we found out about a really cool technology called Apache Calcite. And you can view Apache Calcite as a sort of database engine, but without an underlying storage engine. So it can do query parsing, query planning, optimization, but it doesn't actually execute the data retrieval itself. It fans this out to all kinds of underlying data stores and services through what is called Calcite adapters. And you can also create your own adapters, so it doesn't have to be something that comes pre-cooked from Apache Calcite. So this is actually a really amazing technology, which allows us to take these queries defined by business users, put them into Calcite, will be turned into an execution plan that will be executed across our services landscape. So really cool, but also a very big bet, because when we wanted to adopt this technology, there was no 1.0 release in sight. There was also a complete lack of knowledge on our side for this technology. We didn't know it yet. So we wanted to explore. We needed to learn about this. And we also already knew that at that point, it didn't support all of the functionality that we would eventually need. So all in all, this is a pretty big bet. And we will be exposing this platform to business users with all of the risks entailed with that. So the question, of course, becomes, what could possibly go wrong? And actually, that's the exact kind of question that you should ask yourself in this situation, to set yourself up for this intelligent failure. Because we wanted here to play to win and not to play not to lose, right? So this is something that is a very big bet from a platform and a technology perspective, but it also has a huge upside in terms of how our product would evolve and the flexibility that it would afford. So what do you need to do in that case? Well, if you want to fail intelligently, then you need to fail often, but you also need to lower the cost of failure. And there's a few elements to that. So on the one hand, what you really need to have there is a way to do these kind of changes, these new technology introductions incrementally. So luckily, we already had quite a lot of infrastructure in place to do incremental rollouts, also to do A/B testing. And obviously, you don't start big bang with replacing your whole platform, but you try to find this very interesting but small vertical slice that goes across the whole tech stack to actually prove the point and to incrementally learn and see how you can adopt such a technology. But of course, that's only part of the deal, right? Because as we say, a feature isn't done until it's observable. Because you can roll out whatever you want, but if you don't have any insight into what it does and where it fails and how it fails or how it works or how it doesn't work, then you're nowhere. So we put a lot of effort into also instrumenting Apache Calcite and all of the systems that we built around that, so that you could very precisely see what it was doing in production and what was working and what wasn't. And here's, for example, a very specific graph that we created for the Apache Calcite underlying executor, where you could monitor the queued threads, which is obviously a bad thing. So yes, things did go wrong, and I'll get back to that in a bit as well. But these are the insights that you need to do intelligence failure, to learn, to have these very small cycles, and to step by step adopt this kind of new technology until you end up with a completely new platform. And these are all technical points, but what I think is even more important is to create a culture in the team to do this, to learn, to make it safe, to be able to pull the ending cord. The ending cord, what's that? Well, that's actually an invention that comes from the Toyota factory, where they have this yellow line on the assembly lines, and anyone can pull that line when they see something out of the ordinary, right? So if you see something that's just not right, then you pull it. It doesn't immediately stop the line, but it gives you think, 60 seconds to together with the supervisor triage and see, do we really need to stop the line? And then everyone is allowed to make that call. And that is, I think, a very important aspect that you need to have in your company to do these kind of big changes, to also be able to intelligently fill. Because if you don't speak up when there's a small failure, everything will snowball into bigger failures. And at some point, you will not get out of this anymore. So our endon course is actually the /inc command in the Slack. So anyone can raise a production incident. And everyone is actually encouraged to do so whenever you see something that's just not right. And even if you can't put your finger on it, it's okay. Declare an incident, we'll look at it, we'll learn from it. And that is the culture that we want to have. And that means that we also have false positives. Sure, it happens. But that's a good drill, right? It helps you to see, can I triage this fast? Do I have enough observability to actually get into the actual issue? So that's something that you will at some point also take for granted then. And all of these smaller failures give you incremental information into how you are doing. So this also ties into this psychological safety that I mentioned at the beginning. Make it safe to speak up. Make it safe to admit that there might be a failure. If it's your failure, fine. If it's someone else's failure, also fine. There's no blame here, but make it safe to actually speak about what you see happening. So all that being said, lots of things you can do to lower the cost of failure. What actually happens? Well, unsurprisingly, of course, a lot of things failed. So here's just a random sampling of a lot of the incident reports that involve this new Apache calcite technology. So I'm not going to sugarcoat it. Yes, this also had some customer impact, and there was some failure that people felt, even though we didn't want them to. But we also learned a ton about how this affected our performance using Apache calcite as a database or as a query engine. We ran into the limits, which we also needed to fix, of course, but we could do so incrementally, and we could learn what worked and what didn't work. And we also ran into the fact that, yes, exposing a full SQL platform to business users, while very flexible, also gives them maybe some ideas to do things that they probably shouldn't do, so you need some guardrails there. So what did we do? So a lot of things. So on the one hand, we really got deep into the technology. We tailored it to our needs. So for example, we created this custom calcite executor, which took away a lot of the issues that you saw in the first charts with the queued threads and all of the memory overhead that was in there. So that's one thing that we had to do. But as you get deep into technology and start tailoring it, I think you also have a responsibility to contribute back. So we also upstreamed a lot of our changes back into Apache calcite. And I think, that is also something that's very motivating for the team, right? If you see that you're using a technology in the right way, that also can benefit others, then you've really learned from all the failures that you encountered. So, for example, support for records in some places in Apache calcite has been contributed by Picnic. And ultimately, of course, we also understood more and more that we needed to introduce guardrails for our business users. So for example, whenever they put a query into a template, we now have a tool that will explain to them, this is actually the effect of this query, and do you really think it's worth sort of this performance profile or not? So they can actually trade that off themselves. So also there, lots of learning, but quite a different kind of learning than from the basic failure that we saw with the Node.js instance. And something where we actually used failure to push the boundary and to incrementally get somewhere where we otherwise wouldn't end up. So yes, it is possible to make these kind of big bets, but you need to practice intelligent failure. And that requires a lot of baseline setup to lower the cost of failure with observability, as we talked about, but also in terms of culture and the way you work with these things. So that also means that you need to be prepared to invest if you do this, right? So as you saw, we had to invest a ton into tailoring the technology, also contributing back to the community there. And that takes time, effort, but it is very rewarding. So if you start doing this, and if you start pushing the boundary and having these kind of intelligent failures, you will see a very nice side effect. And that is that you won't only encounter failures where you can learn from, but by having all of this in place, you will also see things that almost become failures, but you catch them before they are. So these near misses, you also increasingly start to catch and to learn from and to prevent actual failures from happening. So I think that's also a very good side effect if you are very diligent about this. So wrapping up, learning from failure, I think I've shown that you can do this and that you should do this, but of course you cannot make all the mistakes yourself, right? So if you do this, if you're in this process, do write it down. Have good incident reports. Write a blog post. Do a conference talk. Share what went wrong, how you fixed it, and why you're now better off. Because if you don't, then you're doomed to repeat it. And you can encourage this by reframing failure, right? Think of the rapid unscheduled disassembly. Failure isn't necessarily negative. It's something that you can actually leverage and use. So I hope there's one thing that you take away from this, and that is failure is just a part of life and part of what we're doing. And if we embrace it, we can actually very much benefit from it rather than be scared by it. And yeah, I really hope that tomorrow, when you get back to your team, that you have an honest conversation about this, that you look at this and maybe change a thing or two. And if you don't, well, maybe then I have failed. But you know what? I'm okay with that. As long as you provide me feedback, I will learn and I will try and I will try and I will try again. Thank you.